Good morning. In this video, we will discuss the topological sort algorithm. This algorithm is for a topological sort. It's very simple. This algorithm will enable us to visit the vertices or order the vertices of a graph in topological order, sorting order. Okay. So this is the basic idea. Let's see the algorithm. So here for there is a for loop for I starts from 1 to set of vertices, number of vertices in a graph. Then inside the loop, what are we doing? We find a vertex, call it as V, which is having in degree 0. Okay, so we find a vertex with the in degree 0. Let's assume sometimes in a graph you may have more than one vertices with in degree 0. So in that case, how are you going to select a particular vertex and visit that vertex? Basically, you can follow any order. Let's say you find two vertices with in degree 0 like A and C. So you can pick any and you can select any and visit any, but we are going to follow a unique way of visiting the vertices of a graph. So that unique way is you are going to pick the vertices in alphabetical order. Like A and C means you will be selecting A, not C. So that is the technique we are going to follow. After you find a vertex, then add that vertex in the sorted vertex and then remove it from the graph. Not only the vertex you are going to remove from the graph, also the associated outgoing edges starting from that V, okay, outgoing edges from that digraph. So these are the three steps we are going to do. Okay, let's see a simple directed graph is given in the example. Let's see how the visiting is done, how the vertices are visited using the topological sorting order, using the algorithm. So first step is I need to find a vertex with in degree 0. So let me calculate the in degree of all the 10 vertices given in the diagram, in this graph. Okay, so in degree means inward edge coming to that vertex. How many coming? How many inward edges are coming? For A, only one inward edge. So the degree in degree is 1. For B, two inward edges. Degree is 2. For C, three inward edges. So the degree is 3. For 4, nothing. So 0. For D, it's nothing. For E, it's 2. There is an edge 1 here, inward edge, not the outgoing. So this is outgoing, this one. Okay, for F 1, for G 0, for H 2, for I 1, for J 0. I told you already, you can pick any vertex with the inward in degree 0. But here, let me list out and then let's use this strategy to pick or to select a particular vertex. Which of the vertices having in degree 0? D, G and J. G, J. Pick the one in alphabetical order. So, which comes first in alphabetical order? D. So, that one I visit first. I already gave the sorting order. So, let me see which one comes first by ticking. I put a tick here so you can understand. Fine. Now, after you visit it, I told you, you need to remove that edge. Also, sorry, you need to remove that vertex. Also, all the outgoing edges of that vertex. Not only the vertex, the outgoing edges. So, I removed all the edges on the so all the edges of D, also the D. Now, what will be the in degree of C? It's no more 2, sorry, no more 3, it's now 2. Because I removed 1. How about I? Supposed to be previously 2, now it is 1. Okay, previously there was down here. So now it is 1. How about H? It is 1 only. And E also affected because I removed this edge, so it will be 1 only. So I is 1. Previously I was 2. Okay, now it is 1. Fine. Now let's list what are the vertices having in degree 0, which is G and J. So alphabetical order, you pick the vertex G. Visit that vertex. Okay. Remove G from the graph. Also its associated edges, associated edges. So when I remove the associated edges, so what is the in degree of A now? 0. There is no incoming edge. F is fine. For B, the in degree is 1. For H is 1. For C, it's no more 2. It is also 1. But I is fine. J is fine. Now list out which of the vertices having in degree 0, A and then J. So you will be visiting A. Can you see here? Remove A. Also the associated edges from the graph. So the in degree of F is 0. B is also 0. C is fine. Okay. The rest are all fine. Now list which of the vertices having in degree 0, B, F, J. So now in alphabetical order, we will pick B and visit. And now remove B. Now what will be the in degree of C? Fine, same. What will be the in degree of H? 0. F is same. Okay. So which of the vertices having in degree 0? F, H, J. So you will be visiting F. In the visiting order, the next vertex you pick is F. So remove F from the graph and the associated edge. There is no associated edge. Fine. Find out which vertices having in degree 0. Only H and J. So remove H and visit H also. Okay. Only H. There is no edge coming out of H. The vertex H. Okay, fine. No problem. And find out which of the edges having in degree 0. J only. Because the rest are all 1. So visit J. Fine. Whenever you visit that particular vertex, remove the vertex from the graph, also the associated edges, outgoing edges. Now, the pending is C, I in E. C in degree is 1, I in degree is 1. For E in degree is 0. This is outgoing edge. There is no incoming edge for E, 0. So only one vertex having in degree 0. So no need to select alphabetically, we have only one vertex. So visit E. Whenever you visit a particular vertex, remove it from the graph. Also the associated outgoing edge also. So here in degree is 1, fine, but for I in degree is 0. Okay. So now you need to find the vertex with in degree 0 and add to the sorted vertex. So I add it and remove it from the graph. Now you pending with only one vertex with C. There is no incoming edge from any other nodes. So the in degree of C is 0. So now visit that vertex C. So this is the list of nodes and remove it from the graph. So you can see that all the vertices in the graph were visited because the loop says from 1 to the number of vertices in the graph. How many vertices we had? 10. So 10 iteration will be there. So we have visited all the vertices. So this is the topological sort order for the graph given above because it was deleted. You remember the graph. For that graph, this is the topological sort order. Thank you.